Okay, good afternoon, good evening, or good morning, anytime you a chance to watch this video. So, to have a class now, so I'm expecting you to join, but I can't wait because I need to cover some ground. So, the video will be available for online. So, I'm going to start immediately. We are still in introduction to Matlab. I'll be sharing my screen now. Uh, I want to recommend this this um, this website, tutorialpoint.com, Matlab. So they have a good, uh, you know, uh, compilation on Matlab. So I want to quickly introduce us to some of the things that people are complaining of installation. I've done a video on installation, but it's like a quick summary for those who are still having problem with installing. For now, I expect you to be able to install very well. So I want to quickly do that. Then I will move to syntax, and then I'll do variable. I will do command for this short time I have here. So quickly, I'm going to enlarge the screen. If you are seeing this now, I'm going to enlarge it so that, okay, I'm going to enlarge the screen. Okay. Okay. So you can see, I want to look at the environment setup, local environment setup for Matlab. Setting a Matlab environment is a matter of few clicks. The installer can be downloaded from this website for the student version or a trial version, and you can follow the other um, procedure I gave you on that CD. You need to log into the site and wait a little for the approval. After downloading the installer, the software can be installed through a few clicks. You can install using internet. You can install using without internet if you have the disk. And then you say next, and then this one takes about 40 minutes, but at times it can take up to 1 hour or two depending on your system speed. Like the version that we have, you know, it can take up to 2 hours thereabout, and then you can now do. So when you finish, then you have the environment. This is the environment we talk about. Um, so this is the desktop. Um, this is the command window. This is we have the current folder. Then we have the command window, which is this. Then we have the workspace. Then we have the command history. You can use the up and down arrow to bring up the last history you have done. So quickly, I am going to uh, just assume that you have installed the MATLAB from our previous um, discussion. So I'm going to go to the syntax quickly. I want to go to the syntax. Okay. Now, MATLAB has basic syntax you need to be conversant with. Your familiarity with this will help you. Okay. MATLAB environment behaves like a super complex calculator. Okay. You can enter commands at the command prompt. Okay. And MATLAB is an interpreted environment. So take note of that, an interpreted. We have a compiled, uh, you know, and then we have interpreted environment. So in other words, you give a command and MATLAB executes it right away. Okay. Now this is just like a hands-on practice. If you type 5 plus 5, you will get the answer will come up. Answer is equal to 10, which we have done before. Um, 3 raised to the power 2, you have that. This is the comment. Percentage is comment in MATLAB. The answer will be 9. 3 raised to the power. Then you have sine bracket pi over 2 bracket close. That is sine of angle 90. Then you are going to have 1. Then this is another example when you say 7 divided by 0, divide by 0, that's the comment here. You can click on live demo on the website if you are on tutorial point. It will use uh, GNU Octave, which is very close to, which is an open source alternative to MATLAB. It will be giving you all these things. And you that have already installed your Matlab, you can see it immediately. I'm going to show you some example as time goes on. Answer will be infinity, okay? Because it's division by 0, it's infinity. Then we have another one here. 732 divided multiply by 20.3. Then when you click on it, you will see the answer. It's a 1.4860 to the power of 4. That is this is exponential. That means times 10 raised to the power 4. Okay. MATLAB provides some special expression for some mathematical symbol like pi. You see inf for infinity, I and j the um, for the for the square root of -1 negative, which we call complex numbers. Um, then we have NaN, which stands for not a number when the result is not a number. Now we also look at the use of semicolon in MATLAB. I've talked about it before, but I need to emphasize it, okay? I need to emphasize it, okay? Now, use of semicolon in MATLAB indicates end of statement. However, if you want to suppress and hide the MATLAB output for an expression, you need to add a semicolon after the expression, okay? So you don't want MATLAB to send that thing back to the screen. Whatever you enter at the screen, you press enter without semicolon, MATLAB will send it back to the screen to you. For instance, we have done that a lot of times, so I don't need to repeat that. This is just a quick recap, okay? Now, if you do x is equal to 3, then y is equal to x plus 3. So it will not send this x equal to 3 to the screen because of this. And if you say y is equal to x plus 5, if you put semicolon here, it will not send this, okay? So you can see. Then we also look at the comments. When you want to add comments, percentage sign is used for indicating a comment line, like a remark in other programming languages like BASIC, Fortran. You can write a block of comments using the block comment operator percentage. Okay. MATLAB MATLAB editor includes tools and content menu to help you add, remove, or change the format of comments. Okay. Now, comment is important when you want to make your program explicit. You want to make it well understood, even by yourself, because there are times you do something in a programming session and you want to refer to it again, but you don't know what you have done. So you may need to add comments so that you know what you've done, so that anyone that reads that program will understand what that line is meant for or what is actually going on. So comments are very, very important in your programming skill. As you develop your programming skill, learn to add comments to make your program readable and understandable at a later time. Now, the next thing is commonly used operators and special characters, which we have done before, but I need to do this explanation so that you'll be able to understand. Now, we have a plus sign, which is just addition operator. Minus is subtraction. Then we have scalar multiplication, just the asterisk. Then we have dot star. Dot asterisk is an array multiplication operator. When you have dot asterisk, is array multiplication operator. That means it's going to multiply each element in the array one by one. So that's very important. Then we have the exponential operator, that is raised to power. Then we have the dot exponentiation, which is an array exponential operator. Then we have the left division operator. Then we have the right division. So in MATLAB, we have both left and right division. So the left starts from left, ends at the right. While the right starts from the right, ends at the left. So we're going to see their use as I've explained earlier. See, you will know the left division is just like the normal um, uh, division. I mean, uh, we have uh, we have the right division like the normal division. Then the left division is going to be giving us an inversion. Okay, we're going to see that later. Then we have the dot left division, which is an array left division operator, and then we have dot right division, which is an array right division operator. Then we have colon. Now, colon is going to be very, very, uh, you know, it's good we look at colon in a detailed manner. So colon generates regularly spaced element, represent an entire row or column. Okay, sorry for the interruption. Now, we have the array. I'm looking at the colon here. Colon will be used, most of the time, and you need to know that. We're going to see it generates space element and represent an entire row or column. Okay, so colon double, that is colon, not semicolon. Now that is the full colon. Okay, generate regularly spaced element and represent an entire row or column. You're going to see it's very much versatile in Matlab. Then we have parentheses, that bracket, encloses function arguments and array indices, overrides precedence. Okay, and you have BODMAS, bracket, of, division, multiplication, addition, subtraction. So it overrides precedent. It must, bracket is the first thing to be tackled when you have an expression or an equation. Then we have this is parentheses, that is brackets, parentheses. Okay, welcome, Aminu. Yes, welcome. Okay, welcome on board. I'm going to upload this video so that people can go through it because of the challenges of power. Many of you may not be able to connect, but I will upload. So we have a bracket, enclosure, array element. We have decimal point, dot. We have 3 dots, ellipsis, line continuation operator. And we have comma, separate statements and elements in a row. We have semicolon, separate columns and suppresses displays. Then we have percentage, percent sign. There's a comment or specifies formatting. When you want to use it to format the output that is going to be displayed when you are printing or when you are sending something to the screen. Then this code sign or transpose sign. Now this does not show properly. Then we have non-conjugate transpose operator. Then we have assignment operator. Okay. Then we have special variable and constants. These are special variable and constants that you should not tamper with. Don't use them for your variable names. ANS is for most recent answer. EFC is for the accuracy of your floating point precision. I, J is the imaginary unit, which is square root of -1. Then INF is infinity. None is undefined numerical result, not a number. Then we have pi, which is the number pi, which should be 20. I've forgotten 22 over 7 or thereabout. 3.14 something. Now, as you come in, just listen and follow on and mute yourself. Now, naming variables. Variable names consist of a letter followed by any number of letters, digit or underscore. Now, Matlab is case sensitive. So variables are case sensitive. the same name with the same name, a variable with the same name, but just a difference in um, in the first letter capitalized will be different from. So we're going to see example. Now MATLAB is case sensitive. Variable names can be of any length. However, MATLAB uses only first n characters, where n is given by the function name length max. Okay, that's maximum character. Then saving your work, save command is used for saving all the variable in workspace as a file with .mat extension in the current directory. You can say save my file, but in our interface, we normally use the save icon there. Then you can reload the file anytime using the load my file name. Okay, now this is something that we should get familiar with. Now we are moving to variables now. Now I want to look at, in MATLAB, we are looking at syntax, and I want to look at variable in particular. In MATLAB environment, every variable is an array or matrix. Don't forget, is an array or matrix. You can assign variables in a simple way. For example, x is equal to 3. This is the comment defining x and initializing it with a value, which is 3. MATLAB will execute the above statement and return the following result: x is equal to 3, because there is no suppressing semicolon. If you put semicolon, it will not return this. It will store it in memory without sending it to the screen. It creates a 1-by-1 matrix. So this is a 1-by-1 matrix. Name x and store the value of x and store the value of 3 in its element. When you check up the example, you will see, and when you check in the MATLAB, you will see the OS. So we have done this. So I expect it to be formatted. That's why I'm very fast, because I'm on battery now. I'm on battery. Let us check another example. X is equal to square root 16 in bracket. Now, this square root is a function to define x and initialize it with an expression which is equal to square root of 16. MATLAB will execute the above statement and return the following result: x equal to 3. X equal to 4. Sorry. Now, please note that once a variable is entered into the system, you can refer to it later. Variables have values before they are used. When an expression returns a result that is not assigned to any variable, the system assigns to a variable named ans, which can be used later. So square root 78 will be assigned to ans. So ans, you can now say square root 78. If you say, you can use this variable ans, you can now say 9876 divided by ans. That whatever is now stored in ans will be used to divide that. So you can see. So yeah, and you now replace it by the new answer. So this is the answer, and like that. Now let's look at another example. X is equal to 7 times 8, and then y is equal to x times 7.89. So you can see this, because this one was suppressed, and then this one was not suppressed. So you see the answer. So this one will be executed and stored in memory without being sent to the screen. This one will now be sent to the screen. To take the result of x, put it here, and multiply by 7.89. Okay, now we also have multiple assignment. A is a 2, semicolon, B is equal to 7. So all these things are assigned on the same line, and they are being suppressed. Now, when you now say C is equal to A times B, it's going to have this answer. Now, I'm forgetting the variables. What can you do? The who command displays all the variable names you have used. So you can use who to bring out all the variables you have used. So it's very, very handy. Now, we also have MATLAB will execute the above statement and return the following results: A, answer, B, and C. That is, this is who tell you A, ans, B, and C. These are ones that have been available. Okay. Then you have the whose command display little more about the variable. The variable currently in memory, the variables currently in memory, type of each memory variable, memory allocated to each memory allocated to each variable, whether they are complex number or not. When you type whose, this is what you see: the size, the byte, and the class. Okay. Then you see total is 73 elements using 781 bytes. The clear, we'll talk about this. Clear commands delete all the variable from the memory. If you declare X, if you say clear, delete all variable. Can you say clear all? In the display, it won't delete X. Won't I mean it will delete X, won't display anything. Okay. Now clear, it will delete all variable in workspace, display, and unobstructedly. You can also use clear all. Okay. Now long assignment can be extended to another line by using 3 dots. Okay, 3 dots. Just listen, just listen. This is a recorded, it will be recorded. So I don't want, sorry, you can't hear me? Why can't you hear me? It should be your network. Don't worry, I will upload the video. The video will be clear for you to look at. I can't, I can't, I can't waste time because I'm on battery and I'm on data. Long assignment can be extended to another line by using ellipses. So if you have 3 dots, it means it is extended to the next line. Okay. If you have initial velocity as you jump into gravity, then time, then velocity is equal to this. Now you have this. So you can extend. Yes, when you have long, you can use to extend to the next line. Okay, that's what I'm trying to explain here. Then the format command. This is known as short format, and you can also have format long. So when you say format long, it's going to give you 16 digits after the decimal. Short format is going to give you just the few digits. This will be, short format, about 3 digits. One will say about 16 digits after that. Format bank, okay, it will give you that is the short, okay. Format bank commands rounds numbers to 2 decimal places, okay. Format bank rounds up to 2 decimal places, okay. Format short E, okay, allow display in exponential form, okay, with 4 decimal places plus the exponent. Okay, this is what it's saying here. Format short E. Format long E displays an exponential form with 4 decimal places plus the exponents. Okay, that's it. Format RAD commands give the closest rational expression resulting from a calculation. Okay, this is Matlab will execute and return the following format RAD. That is the rational expression, the closest rational expression. Now we have vectors. A vector is a one-dimensional array of numbers. We have row vector, column vector. So when we are creating vectors, you can just use your brackets, okay? It will give you this row vector. When you use this and this, you see. But when you use semicolon, when you use comma or the same, to give you row vector. But when you use semicolon will create column vectors. Okay, it will create column vectors, vertical. Row vectors are horizontal. Okay, when you want to create matrices, you can separate them with a matrix, a two-dimensional array of numbers. We have talked about that before. So this is when you put semicolon, it will create. You have the row and the column. Okay, so this is 1, 2, 3, the row. Then this is another row. Then this will be column. 1, 4, 7 will be column. 2, 8, 2, 5, 8 will be column, and then 3, 6, 9 will be column. Okay, now let me quickly finish up with this. I don't want the video to be too long. I want to look at commands that you will need in MATLAB. Commands. Commands are very important in MATLAB. MATLAB is an interactive program for numerical computation and data visualization. So you can actually enter a command by typing it at the MATLAB prompt. That means on the command window. This is the MATLAB prompt. You see it? Okay, this is MATLAB prompt. These two greater than. Anything you type in the front will be executed as a command. And it is normally in the command window. Now we're going to look at commonly used general MATLAB commands here. Commands for managing a session. CLC clears command window. Clear removes variable from memory. Exit checks for existence of file or variable. Global declares variable to the global. Help searches for a help topic. Look for searches help entry for a keyword. Quit stops MATLAB. Who lists current variable. Whose lists current variables long display. Now let's look at commands for working with system. With the system, CD can change your current directory. Date can display the current date. Delete will delete a file. Diary switches on and off diary file recording. There are lists all files in the current directory. Load loads workspace variable from a file. Path displays a search path. PWD displays current working directory. Save workspace variable in a file. Type display content of a file. Word lists all MATLAB files in the current directory. WKL read .wic1 spreadsheet file. That is wic1 whatever. Then input and output commands. MATLAB provides following input and output related commands. Display content of an array of string. fscan fscanf read formatted data from a file. Okay. Format control screen display format. fprintf perform formatted writes to screen or file. Okay, you can see fscanf only reads format data from a file. Reads formatted data from a file, while fprintf performs formatted write to screen or file. Okay. Input display prompt and wait for input. Then this is semicolon, suppresses screen printing. Now let's look at the difference between fscanf and fprintf. They behave like cscanf and printf if you are confident with C programming language. They support the following: %x format as a string, %d format as an integer, %f format as a floating point value, %e format as a floating point value in scientific notation, %g format in most compact form, %f or %e. /n insert a new line in the output string. /t insert a tab in the output string. Okay. Now let's look at the format function. We can format short, 4 decimal digits default. Format long, 16 decimal digit. Format short e, 5 digit plus exponent. Format long, 16 digit plus exponent. Format bank, 2 decimal digits. Format plus, positive, negative, or 0. Format rat, rationalized approximation. Format compact, suppresses some line fits. Format loose, reset to less compact display mode. Vector, matrix, and array commands. Very, very important. That's why I'm doing it, for you to have a kind of overview. When you need them, you can easily go back to our MATLAB help, and you get more on them. The following tables show various commands used for working with array, matrix, or vector. Very, very important. You will see command cat concatenates array. Find indices of non-zero element. Length compute number of element. Linspace creates regularly spaced vector. Log space create logarithmically spaced vector. You can see linear space. This is log space and space vector. You see max return largest element. Mean return smallest element. Prod, this is product of each column. reshape, changes size, compute array size, sort each column, sum each column, create an identity matrix, ones, create an array of ones. These are actually functions that are already defined in Matlab. Zeros, create an array of zeros, cross, compute matrix cross product, dot, compute matrix dot product, determinant, compute determinant of an array, inverse, INF, compute inverse of a matrix, P and L, that is pseudo inverse, compute pseudo inverse of a matrix. Then we have rank, compute rank of a matrix, rref, compute reduced row echelon form. Then we have cell, create cell array, cell display, display cell array, cell plot, displays graphical representation of cell array, num to cell, convert numeric array to cell array. Deal, matches input and output list. So this will be used as you look at them. You can look at their usage. Our time is not there. We have to cover all this before we move to AutoCAD. AutoCAD will be our last package on DCE110, Introduction to Computer Design and Drafting. Then we have a cell, identify cell array. Now plotting commands, you need to know them. Very important. ASIC, set axis limits, fplot, intelligent plotting of function, grid, display grid line, plot, generates XY plot, print plots or save plots to a file, title, put text at top of a plot, X label, adds text label to X axis, Y label, adds text label to Y axis, create axis objects, closes the current plot, close all plots, figure, opens a new figure window, G-text, enable label placement by mouse, hold, freezes current plot, legend placement by mouse, refresh, redraws current figure window, set, specify properties of objects such as axis, subplot, create plots in sub windows, text, places string in figure, bar, create bar chart, log, create log plot, polar, creates polar plot, semilog file, create semilog plot, logarithmic abscissa, semiloggy, creates semilog plot, logarithmic ordinate, stairs, creates stairs plot, stem, creates stem plot. So you can see these are very, very important. Let me see whether I still have time to cover the next. These are basic things you need to know. Then the mfile. Now these are so far we have used Matlab environment and calculator. Now we need to we have also started doing little programming. Now Matlab is a powerful programming language as well as interactive computational environment. We're going to look at the M files. We want to create files. We have scripts. They have .m extension, and we have function. And they are also saved with .m extension. Now, scripts are program files. You write series of commands which you want to execute together. A script do not accept inputs and do not return any output. They operate on data in the workspace. Okay, but functions, they are also program files with .m extension. Function can accept inputs and return outputs. Internal variables are local to the function. Okay, so this is one of the things you take note of. You can use the Matlab editor or any other editor to type your .m files. In this session, we discuss script file. Now, you can use the command prompt. You can use the IDE. So you can type edit, and then this will open the editor, or you can type edit then the file name. It will open the editor with the file name already created with .m extension. Now, the above command will create the file in default Matlab directory. You want to store all program files in a specific folder, then you have to provide the entire path. So you can create a folder name props for the program, for all the programs you'll be writing. You can type the following commands at the program. You say mkdir, that is make directory props. This will create directory proc under default directory. Change directory chgr, this is change tree props. We change the current directory to props. Edit prog1.m. Create an m file named prog1.m. and it will be in that directory. Okay, so you can see, when you see that, this is it. Then you can type this and run it, and then you will see it happening. I don't want to waste time because we're going to see do some programming example shortly. And I don't want the program. I don't want the video length to be too long, so that it can be easily uploaded. Now you can look at these examples and create a script file using this code. Okay, make sure that you type it and you save it in your Matlab script file. Okay, so I'm going to stop here. I'm going to stop here. Okay, it's like I still have. Um, I need to do. Let me do data types quickly because of data types. I need to do data types. Now we need to do data types in Matlab. Very very important. We have int 8-bit signed integer, uint8 unsigned. When you see u is unsigned. When you see no u, it is the integer. Okay, it is the signed one. Okay, 16-bit signed, 16-bit unsigned for u integer, 32-bit signed, 32-bit unsigned, 64-bit signed, 64-bit unsigned, single precision numerical data, double precision logical value will be 1 or 0, which represent true or false. Character char will give you character. Cell array will be array of index cell capable of storing an array of different dimensions. Structure, C-like structure, each structure having names, fields capable of storing an array of different dimension and data type. Function handle, pointer to a function. User classes, object constructed for user-defined class. Java classes, object constructed for Java class. Now you can create script with this and try to test them. You can pause the video and create this and test them just for exercises. Now we have data type conversion, for conversion purposes. Character converts character array, convert to character array string. Then integer int to string, convert integer data to string. Match to string, convert match to string. Num to string, convert number to string. String to double, convert string to double precision value. String to num, convert string to number. Native to Unicode, convert numeric bytes to Unicode character. Unicode to native, convert Unicode character to numeric bytes. Base to decimal, convert base n number string to decimal number. Bin to dec, convert binary number to decimal number. Sorry, convert binary number string to decimal number. Dex to base, convert decimal to base n number in string. Dex to bin, convert decimal to binary number in string. Dex to hexadecimal, convert decimal to hexadecimal number in string. Hex to dex, convert hexadecimal number string to decimal number. Hex to number, convert hexadecimal number to string. Convert hexadecimal number string to decimal to double precision number. Num to hex, convert single and doubles to IEEE hexadecimal string. Cell to mat, convert cell array to numeric array. Cell to struct, convert cell array to structure array. Cell string, create cell array of string from character array. Mat to cell, convert array to cell array with potentially different sized cell. Num to cell, convert array to cell array with consistently sized cell. Let me see. That's 3 o'clock. Okay. Struct to cell, convert structure to cell array. Now let's look at determination of data types. Function, these are the functions. All these things are actually functions, okay, that Matlab has created to help us. So there are functions that have been created. You can see is detect, this is for determination of data types. Is detect state, is A, determine if input is object of a specified class, is cell. Now you would get to know this as you start meeting them in programming, programming examples or the one you're writing. Is cell, determine whether input is a cell array. It's going to help you to determine something before they take action. So this is very, very important. Previous function for identifying data type of a variable before you take action on that. Is cell string, if input is cell string, is a cell array of string. is character. Determine whether item is a character array. Is field, whether input is structural array field. Is float, determine if input is floating point array. Is HG handle, true for handle graphic object handles. Is integer, determine if input is integer array. Is Java, determine if input is Java object. Is local, determine if input is a logic, is logical, sorry. Is logical, determine if input is logical array. Is numeric, determines if input is non-numeric array. Is object, determine if input is Matlab object. Is real, check if input is real array. Is scalar, determine whether input is scalar. Is string, determine whether input is character array. Is struct, determine whether input is structural array. Is vector, determine whether input is vector. Class, determine class object. Validate attribute, check validity of array. Whose, list variable in workplace with server. So we have come across. So these are example of script file you can create and test them. When you run them, you will get this. So you can pause the video while you type this. Okay. And when you run the file, it should produce the following results. And these are the results you will get. And try to check them. It's a way of practicing for you to know what they are. So I'm going to stop here for the moment. I will upload the video for you people to see. You can see there's no light, there's no network. I'm using data here. So I'm going to stop here. Make sure you go through and go through the exercises I've just shown you people. We'll see again. I will do another video very soon. We are trying to cover everything on Matlab this week so that we can move to AutoCAD by next week. Thank you for your attention. Are you still there, Aliyu? Okay, bye-bye. Yeah, Musbao, what have you? I can't see your name. 1008, 1002. Okay, thank you for being there. I can't take any question now. Just watch the video again because some of you complain of internet connection. So if you don't watch the complete video, you'll not be able to ask any question that, you'll not be able to ask, relevant question. So thank you for attending the class. Bye for now. I'm going to stop the meeting now. Bye. Yes, I've seen your comments, so don't worry. Yes, say you're not hearing properly. Yes, yes, it's network problem. So when I upload the video, you will go through and then you have a good understanding.